Hi guys, today we are going to see how to sketch the root locus with complex poles as well as zeros here in lecture 8 control system, and this is vanilla. So a unity feedback control system has an open loop transfer function g of s is equal to k into s plus 9 divided by s into s square plus 4s plus 11. Sketch the root locus. So we have already seen in a previous lecture that how to solve this problem, find the values in a step-by-step manner. So I have given the link for that with lecture video in the description. So in this video we are going to focus on how to sketch the root locus. So these all values we have already found.
Now let us sketch the root locus. So for the function g of s is equal to k into s plus 9 divided by s into s square plus 4s plus 11. So first we have to take your x-axis, the real value in x-axis and imaginary value in y-axis here. So 1 to 9, minus 1 to minus 9, 1j to 10j, 1j minus 1j to minus 10j. Right, so now we have to plot the stepwise we have to plot the graph here. So the first step to find the root locus is we have to find the root poles and then the zeros here. So in this problem, so your pole, it has one pole, that is minus 9. So the pole has to be mentioned by this bubble here, and then you have three poles here. So 0 should be mentioned in bubble and pole should be mentioned in the cross mark. So the poles are 0, minus 2 plus j 2.64. So this is minus 2 and then j 2.64. So this is going to be a j 2.64. And then this is going to be minus 2 minus j 2.64. So after marking the poles and zeros, so the second point is to find the root locus here, right? So after taking the test point, after each and every pole, we have to find the right side of the test point, how many number of poles and zeros are available. So in between 0 and minus 9, I can take the test point, any test point, and then we can check. After this, I have only one pole, so that too we have to consider only the real axis. So the possibility of your poles is from 0 to minus 9. So in your step 3, so finding your centroid and then the angle of asymptote. So we have found the centroid as 2.5. So mark this 2.5. And then the angle of asymptote is going to be plus or minus 90 degree. So I will be marking the asymptotes here. So 90 degree is going to be your straight line. So using your dotted dashed lines, I will be marking the centroid. So it's going to be the centroid and then the asymptotes. So this is going to be your 90 degree. This is going to be your minus 90 degree. So the step 4 is to find the breakaway point. So since it doesn't have adjacent poles or adjacent zeros, break-in and breakaway point is not possible. And then step 5 is angle of departure and angle of arrival. So here we have complex poles. So we know that we complex poles, angle of departure is possible. So we have found the angle of departure here. So the angle of departure is minus 16.5. So we have to find the 16.5. So here you just connect this one and here also. So 2.6, right? So we have found connecting your all your this is going to be the reference points we have to, and connect all the poles to this one and then the zeros to this co-reference, and then we found the angle. So in that only we have identified our angle of departure is 16.5. So take your protractor and keep it here in the complex poles, okay, and then get your 16.5. So 16.5 is, so here this is going to be a 15, 16.5, and then you just connect. So here 16.5. So I have marked the 16.5. Similarly, in this complex poles also have to take 16.5. So mark 16.5. So here it's 10, 15, 16.5. Connect the 16.5. So just a little bit you can draw. Right. So this is going to be your 16.5 and this is going to be your 16.5. This is also a 16.5. Okay. So now next point we have found the at which point it crosses the imaginary axis. So it crosses the imaginary axis by 4.4. So this is your 4.4j where it crosses the imaginary axis. Here it is minus 4.4j. So now you just join from the angle of departure. So from the angle of departure you just take a dip and then you can join the angle of departure, and then here also from the angle of departure you connect the minus 4.4j. So you just take a dip and then connect the 4.2. So totally how many root locus are available? So the order of the poles, order of the denominator polynomial is going to be 3. So 3 root locus is available. So one is going to be 0 to in between 0 to minus 9. Other one is going to be the complex poles here. So upside is going to be one root locus. Downwards is going to be another root locus. So this is how to sketch the root locus for the complex poles and then the real zeros.
Thank you guys. We will see in the next lecture. Have a nice day. Subscribe my channel for automatic updates.